Hello again, this is Mrs. Turigno with the 11th page of the Geometry C Semester Exam Review. This video will cover questions 41 through 43, and that includes both number 42s. And I really do apologize, I don't know what happened with the numbering there. I think there was a mistake with the auto numbering or something. Okay, question 41. 41 again deals with this exterior angle here. Okay, so we have an exterior angle here and we have two interior angles here of the triangle. And again, I'm asking you to remember what we know about this exterior angle. What you should come up with is that these two angles put together have to equal that exterior angle. So I'm going to add these two together and set them equal to that exterior angle. Here's what that will look like. 4a minus 2, so there's the first one, plus 6a plus 2 equals 100. Okay. I'm betting some of you might make the mistake of starting by setting these congruent to each other. We don't have any information here saying that they are congruent, so make sure you are not just randomly putting together expressions. Make sure you think about what you know about the angles and how they relate to one another. Okay? Then with solving this, there's my wall. I'm going to combine my like terms. So I have 4a and 6a, and since they're on the same side of the wall, I can just combine them. That makes 10a. And then this is really nice. Here I have a negative 2, and here I have a positive 2. What happens when I have negative 2 and positive 2? They're going to cancel out. It's going to make a 0. So really I'm left with just 10a equals 100. Maybe write that a little closer together. So 10a equals 100. Divide both sides by 10. And I end up with a is equal to 10. That would be great if the question was asking us what a was equal to. But be careful because it's not. It's asking you for the measure of angle W, which is this one right here. The diagram gives us that W is equal to 6a plus 2. So I'm going to take this 10 and plug it in for a, and that will look like this. 6 times 10 plus 2. That's 60 plus 2, which is equal to 62 degrees. And that would be your final answer. So this is another one that I would be really careful. I'm betting that in a multiple choice format you would be offered the option of 10 as one of your answers, just to make sure that you're reading that question correctly. So make sure you watch out for that. Okay, question number 42. And I know this looks a little funny. This is just a right angle marking here. This wants to know what theorem proves that the two triangles are congruent. And the two triangles they're talking about are these two, the one on the left and the one on the right. Well, look at what we have available to us. I know that I have a side congruent here. I have this side and this side that are congruent. And this is a right angle, which means automatically that this has to be a right angle. Okay, remember that wherever you have a right angle, you have another one on the other side. And the other piece of information that's not marked in the diagram, but you are expected to know, is that they share this side in the middle. So by the reflexive property, this side is congruent to itself. Just imagine if you took those two triangles and pulled them apart, that side on side XZ in both triangles would be the same in both. So you have to make sure that you consider that when you're answering this question. Now I have a lot of students who see that this is a right triangle and immediately want to jump to the HL theorem because the HL theorem applies directly to right triangles. Just because it's a right triangle doesn't mean that it's going to be the HL theorem. In this case, I don't have the hypotenuse. The hypotenuse would be this side in this triangle and this side in this triangle. So the HL theorem wouldn't apply. What I do have here is a side, an angle, and another side. And that angle is between the two congruent sides in both triangles. So that would be the SAS congruence theorem. Okay. SAS stands for side, angle, side. And that means that the angle is sandwiched in between the two sides. Okay, let's take a look at the other number 42, which is this one down here. And again, it's asking us what theorem proves that these two triangles are congruent. Again, there's a piece of information here hidden in this diagram that's not labeled for you. You have one pair of sides that are congruent. You have another pair of sides that are congruent. Right here in the middle, though, you have a set of angles that are congruent. I want you to think about how you know that, because you better be able to back it up before you say that that's correct. You know this because these are vertical angles. Okay, and we know that vertical angles are always congruent. So once again, we have an angle between two sides. An angle between two sides. Once again then, this is the side angle side congruence theorem. Just so you know, obviously the answer won't always be SAS. You also have the SSS, which is the side-side-side theorem. You have ASA, which is angle-side-angle. You have AAS, which is angle-angle-side. And you do have the HL theorem that works only with right triangles. Okay, last question here. Suppose that triangle ABC is congruent to triangle DEF. I want you to list all pairs of corresponding congruent parts. I would actually not draw a picture here. And I know that goes against every tip and every piece of advice I've ever given you. But I find that this question is actually easier to answer without a picture, with just looking at these letters. Think about what all the parts of a triangle are. If I have a triangle, I have 3 sides and I have 3 angles. So that means I'm going to have 6 sets of parts that I can put together. Let's start with the angles, because the angles are really easy. I know that angle A in the first triangle would have to be congruent to angle D in the second triangle, because they're in the same position in that congruent statement. Let's then go to angle B. Angle B in the first triangle would be congruent to angle E in the second triangle. And angle C would be congruent to angle F. Okay, so those are the angles. We still have to do the segments because this wants all parts. Okay? Remember, segments we name with 2 letters. So I'm going to start with segment AB, and that would be congruent to DE in the other triangle. Again, you're still just picking the letters that are in the same positions. There's A, B, and D, E. Now I'm going to do B, C, and E, F. And finally, this is the one that's kind of easy to miss sometimes. I would also have another segment going from A to C that would match up with the segment going from D to F. Whoops, I forgot my segment marking there. AC is congruent to DF. Okay, and that's it. Those would be my 6 sets of congruent corresponding parts. Remember, if a question asked you to list all of the possible pairs, you would always have 6 parts, 3 angles and 3 sides. Okay, that does it for this video. 1 page left to go. You are almost there.